Hi, so in this video we are going to do some of the exercises for functions or methods, and this is going to be the very last video for this topic. So let's quickly begin. So what I'll do is that, if you remember, we have gone through all the exercise videos of loops, right? In those videos we had so many questions. So what we'll be doing is that when I was teaching loops, I didn't make use of functions, but we had quite a few number of logics: Fibonacci series, palindrome number, reverse number, Armstrong number, special numbers, and a lot of them, right? So let me quickly open BlueJ. Just hold on. Yep. Let's open BlueJ. So the idea is that we have this leap year, circle, sum product, all these things, right? I'm not going to do all of them. I believe that some of them you can do on its own. So I guess I will go with probably this one, reverse number, the palindrome number, or Armstrong number, and there was another, I cannot find it though. Perfect. Yeah, let's do this thing. I'll do it like this. Let me give you the brief overview. So we'll write a Java program which will ask us enter number. Okay, that's it. So it will ask us something and we will give it some number, maybe say 363, something like this. So after that, what happens is that this will take the number, it will check if it is a palindrome number, then it will check if it is an Armstrong number, it will check if this is perfect number, then this will check if this is even number, then this will check if this is positive number, something like that. Okay, this will check if this is positive number. So basically we are going to use a few things. The first thing that we are going to use is this. Of course, we need scanner class to get the number, get the input from the user, and then we will create function for everything. Like for palindrome we'll have a function, for Armstrong we'll have a function, for perfect, for even number, for positive number we'll have functions. Okay, and all of these are going to be static functions, so it's going to be pretty straightforward. We'll just call the methods and we are done. Okay, so let's quickly go, and we are going to do a lot of copy pasting. By the way, let me put it over here, test 3, or maybe put it over here. Let me see what's inside this. Okay, anyway, I don't need this. Okay, so let's do one thing. What I'll do is that I'll have 2 more classes. Okay, test 3, let it be like that. Test 3, let it be like that. I will create another and I'll call it demo functions. Okay, this is where we are going to write all our functions. Okay, and we are going to make it separate. All the functions will be inside there, but all the computations that we are going to do are going to be over here. So that way we can very easily reuse the functions. That is the concept. Okay, we are not, yes, of course we can write same functions and within the same file we can do the computations as well, but the better way would be to separate it out. Okay, but anyway, I'll show you both the things. Okay, so, and we need to do a lot of copy pasting since we are going to copy the logic from each of the classes. So let's copy paste now. So the first thing I will do is that I need to copy the palindrome logic. Let's see what was the palindrome logic. Okay, This was the palindrome logic, right? I'm not going to explain the logic. If you need to understand why I am doing what I am doing, please go through the exercise videos of loops. There I have explained everything. So what I was doing, I was taking a number from the user, and then the entire logic is happening, right? I'm getting the input, then this, basically this is the logic. This is the logic that we need. Okay, cool. Let's copy it. Of course we need a main method. And public static void main string args. For now we are going to keep it empty because our main focus is on creating the functions. Let's create another function, public static boolean. Boolean is palindrome. So boolean is the type that it will return. Okay, this is the return type of a function, right? This is the return type of a method. So it will return boolean. What was boolean? If you remember, it was either true or false. Boolean is a data type that can only be true or false. So basically what this function will do, this method will do, is that it will check if the given number is palindrome. If it is palindrome, it will return true. If it is not palindrome, it will return false. So it will obviously take a number, and I'll just paste the logic, whatever I have copied. And yeah, oops. Okay. Although indentation doesn't matter, I have a little bit of OCD. Yeah, okay, this looks good. But anyway, we have to return something. We have to return a boolean variable, otherwise this will show us error. What it will show? It will show missing return statement. We need to return a boolean value, and basically what we will do is that if whatever the number that the user has given is equal to the reverse number. This was the logic, right? If the given number is equals to the reverse number, then this is the palindrome number. If this is true, then we can return true. Otherwise we can return false. Return false. Missed the semicolon. Yeah, okay. So very simple. This is the palindrome logic. It will what it will do is that it will just bring out the reverse number. Okay, what is the reverse of the given number that the user has given, and it will check if the given number is equals to reverse number, then yes, it is a palindrome number, it will return true. Otherwise it will return false. Okay, that's the logic. Let's compile, and yeah, let's see. Okay, let's see what happens. Okay, so if what I'm gonna show is this, if oh, anyway, I have to take input from the user, right? So just delete all of these things. I need to import scanner class. Import java.util.scanner. Yeah, now create the scanner object. Scanner sc is equals to new scanner. We're done. Take the input. Oh yeah, sorry, I forgot. You have to specify. System, let's remove this. Scanner system.in. Yeah, cool. So I will say int x is equals to, or I can say n as well, and since you have already studied the scope of variables, you know that this n and this n has nothing to do with each other. This is a separate function, this is a separate function, so I can make it n. Okay, I can name it whatever I want. So anyway, I'll get the user value here, so I just say sc dot next int and I'm done. But anyway, I have to at least like show the user that enter the number. So that's why system dot out dot print, not ln, because I want it to be on the same line. I'll just say enter the number, and that's pretty much it. And after that, what I'll do is this: I will separate the things out. I'm not going to write the logic here. If you see what is the difference here, I was taking the input here, right? I was taking the input here, and I was doing the logic here only, and I was like I was showing the output, if it is a reverse number, if it is a palindrome number or not, like literally. So if I need to use it, let's say if I need to find out palindrome number again, I have to write the entire logic once again, right? If I need to find out palindrome number again, I have to write the logic once more. And if I have to find out if a given number is palindrome number for 5 or 10 or 20 times, I either have to use a while loop where every time it will display if it is a palindrome number or not, and then the user will enter again, that sort of thing. Or I can, or by the way, if it is in separate places, I have to take number from the user and I have to check if the given number is palindrome or not. I have to write it multiple number of times. But here what's happening, I have literally created a function, okay, and I can use this function how many times we want, doesn't really matter. So here I would just say system.out.println. Okay, let's use ternary operator. I usually don't like if else, especially when there is a scope of using the ternary operator, right? So why should we use it anyway? But again, for the basics, let's do use it. So I'm gonna say if what was the name of the function? Is palindrome. Oops. So I'm gonna say is palindrome. I'll pass the user value. Okay. If is palindrome n equal true, then I would say system.out.println palindrome. Otherwise, I'll say not palindrome, system.out.println not palindrome. Okay, that's simple. So what I'm doing, quick recap, I am using this scanner class. I am creating the scanner object. I am taking the input from the user and I am passing the input, whatever the user has given, to is palindrome function. What is this palindrome function? This function. Okay, it takes in the input, it uses all the given logic, and if the reverse number is equal to the number given, if it is the same, like whatever the user gives and it's reverse, then it will return true, otherwise it will return false. That's it. So after this I'll check, is this true, is it returning true? If yes, then palindrome. If it is not returning true, then not palindrome. Okay, let's compile this and see if this works. So class compiled, no syntax error. Let's try. Enter a number. So let's enter a palindrome number. Let's try entering a palindrome number 161. Hit enter. Given number is a palindrome number. So it is working perfectly fine, right? This is working perfectly fine. But we can improve this. We don't have to write so many lines of code. As you know, I do not like to write a lot of lines of code. First thing first, let's do incremental changes. Okay, I will show you every version. So when you are checking a boolean value, listen to me very carefully. If you are checking a boolean value, right, you don't need to say if this is equal true. You don't. Okay, you remember when we were dealing with the other things. For example, if I say if 5 more than 4. Say something like this, 5 more than 4. Am I writing equal true? Am I writing equal true? No, because anyway 5 greater than 4 will automatically give you true, and only if this condition is true, this will trigger. Correct? I am not saying 5 more than 4 equal true. This is correct, you can do that, but there is no point, right? There is no point. You can just write the condition, if 5 more than 4, I will do this. What I am saying is, if 5 more than 4 is true, but I don't need to write it that 5 more than 4 is true, then no, don't do that. It will automatically compute if it is true or false, right? And anyway, you are returning a true or false, and you know that if else will only work if this block is true, correct? So don't specifically write something like that. You just need to write this. Okay, let me show you. Yeah. So if palindrome n equal true, just remove this part. You don't need it. Equal true, you don't need it. Okay. Yeah, that's it. Because anyway, when this will check, let's say I have given 111. 111 is a palindrome number. It will go. It will do all the logic. And 111 is equal to its reverse, which is again 111. It will return true, right? It will return true, and the moment this becomes true, it will execute. So don't write equal true. You don't need to put double equal true inside if else. Please keep that in your mind. Okay, that's the first thing. Will this work? Let's try. Let's compile this class. Class compiled, no issues. Let's try entering 111. Palindrome. Perfect, it works. Okay. So let's close this. This is working. That is perfectly fine. Can I make some more change here? Yes, absolutely. Do you see this thing? If n equal reverse, return true, else return false. I don't have to do this. What I can simply do is this. I can say, look at this very carefully. Return, just return statement. Okay. Then say n equal reverse. If this is true, I'm using ternary operator. If this is true, then of course return true. Otherwise, return false. Very simple. Absolutely simple. Correct? Let's compile this. Okay, there is. Oh, I forgot the semicolon. Lol. Okay, let's remove this. I don't need this statement. Actually, you know what? I just remove the entire thing. I'm just using ternary operator. Return if, what I'm saying, if n equal reverse, then return true. Otherwise, return false. Simple. Let's compile this. Okay, let's see if this works. Again, enter the number. Let's say I have 121. It works. It still works. Can I improve it even more? Can I do that? Yes, absolutely. What you can do is this. That's it. What did I do? I'm not even using the ternary operator. Why? Because when I say n equal reverse, either this will be true or this will be false. Is there any other possibility? No, right? Just send this. This will anyway become true. Or so what will happen if 111 is equal to 111? It will send true. If 111 is not equal to 111, I mean whatever the palindrome number is, it will send false. That is the reason you can simply write this and we are done. We are done. Let's see if this works or not. These are called incremental improvements to the code. This is called refactoring the code. Okay, how can you refactor the code? How can you make your code quality better? Because code quality matters when it comes to software engineering. Anyone can write a code, but not anyone, not everyone can come and write quality code. You understand what I'm saying? So compile this again. Compilation done. Let's run this. Let's see if this works or not. 4 3 4. I don't know. It works. Can I make it even more better? Can I make it even better? Yes. What? Simple. This thing can be changed into a single line. How? System.out.println, and I can say, very simply I can say, is palindrome, and I'll send the user value to this function, to this method, right? This is our method, right? And I'm sending the user input. It will anyway get true or false if it is true, because this question mark literally will work if this is true. If this is true, then we print palindrome. Otherwise, we print not palindrome. Perfect. That's it. We are done. This is how you can refactor your code. Now do you see how neat this is looking? This is looking nice and neat. I missed a semicolon over here. Okay, that's it. We are done. Save this and let's check if this works or not. Compile. Task compiled. Okay, cool. Let's try demo function. Run this. Enter the number. Let's try 1 2 2 2 1. Palindrome. It works like a charm. Correct. Now let's do the same. Let's do the same for what should I say? For perfect number. I just have to copy the logic. This is the logic. I just copy the logic. This is where the logic begins. This is where the logic begins. I just need to copy this. I just need to copy this. And how do I know if this given number is perfect or not? If sum equal n. So I just need to return this. Again, I am going to make a boolean method. If you really want to make it a void method, that's up to you. But I will make a boolean method anyway. Let's make another method. Again, public static boolean is palindrome. Oh, sorry, is perfect. Again, it's a boolean. See, do you see? The return type of this method is boolean, so it can either return true or it can return false. And whenever you do such things, return n equal to, either this will be true or this will be false. So this is perfectly fine, right? Whenever you are doing a comparison, let's say 5 greater than 4, 10 greater than 2, or maybe less than equals to something, whatever, these are logical operators, right? These are anyway going to return true or false only. That's why you just return the comparison, directly the comparison, and it will work. It is bound to work. So int n is perfect. We're going to copy the, did we copy the logic by the way? Let's copy the logic. Let's paste the logic. Yeah. And return sum equal n. So whatever the sum is, if it is equal to the number that was given by the user, if it is equal, it will be true. If it is not equal, it will be false. Again, you just need to copy this line. Just to copy this line. Copy. Go to the next line. Paste the same thing. But just change palindrome with perfect. Palindrome perfect. And again palindrome perfect. Why? This is the function name, right? this is perfect. So I'm just changing the method name like that. So let's check if this is perfect. By the way, what was a perfect number? 6, right? 6 is a perfect number. Let's check why 6 is a perfect number. Again, go through the video, right? Because the factors of the because of the factors. What are the factors of 6? 3, 2 and 1. Okay, add them. 3 plus 2 plus 1, it gives you 6, right? That's why it is a perfect number. Let's compile this and check if this works. Okay, class compiled. Let's go there. Oh, whoa. Yeah, let's run this. Enter the number. Okay, let's enter 6. 6 is the palindrome number. 6 is a perfect number. Why is 6 is a palindrome number? Because anyway, besides 6, there are no number. So it is going to be a palindrome number. Any single digit number is by default a palindrome number. And it is also a perfect number as well. Why it is perfect number? Because the factors are, if you add them, you will get the same number. 6's factors are 3, 2 and 1. So 3 plus 2 plus 1 gives you 6. Like that. So this is also working. Alright. So can we go for some other? This is what? Count digit. Reverse palindrome. Armstrong. Yeah, Armstrong. Let's again copy the logic. Just copy the logic. Logic starts from here, right? Logic starts from here. Just copy the logic. Copy. Come here. Let's create another method for this. Public static boolean is Armstrong. Int n. Paste the logic. Okay, and what it will return, let's check. Yeah, so if arm equal n, that is what it is going to return. Just copy this. Again, I'm not going through how Armstrong number works and all, but anyway, just go through the lecture once, the loops lecture, the loops exercises lecture. You will find it there. So I just need to return this. Return this, and I'm done. Right? If I want to check as well, again just same thing, copy this. Now do you see, this has made coding so much cleaner, so much easier, isn't it? I don't have to write the logic in the same method. Even I don't even need to write the entire logic in the same program at all. I can just open another class and write it. I'll show you how it is done. Okay, not Armstrong. Again change it to Armstrong. Again change it to Armstrong, right? This is the method name. Armstrong. Let's compile this. Okay, works like a charm. Let's go there. Demo functions. Run it. Say 163. Oh, it was 153, right? Anyway, let's run this once again. Wide man. 153. So 153 is not a palindrome number, not a perfect number, but it is an Armstrong number. Okay, this works. Let me check in the internet if there are some example which is maybe both palindrome perfect and maybe Armstrong as well. Let me check once. Okay, it seems that there are no examples for a number that fills all the three criteria. Like there isn't a number that is yet found which is palindrome number and a perfect number and Armstrong number. That cannot be done. But at least what I can see is that 153, well, it's not a perfect palindrome number, but it is an Armstrong number. But I have found another number which is 28. Let me check 28. Okay, compile done, and let's run this. So what happens if I enter 28? Let me check. It is not palindrome number, it is a perfect number. Okay, I found another example of a perfect number. Yeah, this works. You can make as many of them as you want to, right? And by the way, these functions are all reusable, so I'll be using this file for writing all my methods that we'll be doing in this video, right? So let's keep going on. Let's take another example for this. Let's say is there a leap year? Yeah, leap year. Let's copy the logic. Just okay. I mean, yeah, this entire logic works as well, but I mean, we have a single line over here. I can just copy this as well. I mean, yeah, let's copy this probably. Okay, I cannot copy this. It's all text and everything, right? Probably what I should do is this one. I should copy this one. Okay, yeah, this looks good. Yeah, I can copy this one, and I can have a function again. I can say public static boolean is leap year, and again I'll take an integer, and this time I'll just say return this, and this should work probably. Yeah, let's see. Again I just paste something, copy and paste. Not leap. I'll just add year. Not leap year. I'll just say is leap year. And let's try this. Let's compile this. Oh, is this an error over here? What happened? Oh, I'm using, okay, let's take year then. Yeah, now it looks good. Let's run this. Probably, oh, not this one. Yeah, void main this one. Let's run this. Enter the number. Let's enter a number, probably 2024. Okay, 2024 is a leap year, so it works perfectly fine. Okay, let's write a function for the Fibonacci series. Public static int fibo, and I won't explain since I've already explained in the previous video. So I can simply say if n is equal 1 or n is equal 0, then simply return n, otherwise return fibo n minus 1 plus fibo n minus 2, and this works. But can I make it even shorter? Can I do it in a single line? Using ternary operator? Yes, absolutely. I can say return, and I will say now if n is equal 1, the same condition, right? Or n equal 0. If this is true, then return n. Otherwise, return this statement. I'm just using ternary operator. There's nothing new. Else part. This is the else part. I know I haven't used else here, but anyway, you can. And I'll just remove this thing. I don't need it anymore. And yeah, there's our function. We are done. Perfect. That's perfect. Okay, I guess this much is enough. The rest you can easily do, right? So I'll just save this, and I would yeah, this is empty. Just put a semicolon here that says it won't do anything else. Or you can just simply remove this. Let's compile this. Okay, compilation is successful. No, I'm not doing anything over here. Okay, now let's close the window, close this as well. I think I need to, yeah, anyway, oops, doesn't matter really, but anyway. So we have all the functions inside this demo functions, right? Let's open test3, and yeah, inside test3 just remove all these things. I don't need any of these things. And in the previous video I've already shown you how to use methods from other classes. That is what we are going to do here. Okay, see, this is a separate class. Now I'm going to say import java.util.scanner. So I'm importing the scanner class, create scanner object, scanner sc is equals to new scanner system.in. Cool. Take the integer. Maybe what I'll do is that I will print Fibonacci series. Okay, I will print Fibonacci series. So what I'll do is this. For you know what I'm doing? For every nth term, I'll print the Fibonacci series. Okay, so I'll do something like this. I'll get the number first. I'll show user system.out.print, and I'd say enter number. Okay, enter number. And what I do is that I would start a loop for int I is equals to, it will start from the 0th term, of course, starts from the 0th term. It will go less than equals to exactly till n, whatever the user enters. Oh, I didn't take the input, lol. Just let me take the input once. Int n is equals to sc dot next int. I'm taking integer, right? So next int. Perfect. So I plus plus, every time it will increment. And for every single term, I'll get the Fibonacci number. For every nth term, I'll get the Fibonacci term. So I'd simply say, and remember in the demo functions classes, not this one. Let me close all of these. These are not needed anymore. Close this as well. Yeah. In this, every function I have declared is static. But are there any use cases of non-static? We will cover that when we start object-oriented programming, not at this moment. But anyway, all these are static functions. We can simply directly call them by using the class name dot the method that we are trying to use. So what is the class name here? The class name is demo functions. Dot, what is the function name? Fibo. So how would I use this method? I would simply say demo functions dot Fibo, and I would simply put I. For every nth term, I'll get the associated Fibonacci number, and I would simply print the entire thing. System.out.print ln, and yep, let's try and do this. Let's save this, let's compile this, and the moment I do you see this arrow? Do you see this arrow now? It is now pointing to this because it is using the Fibo method within demo functions class. That's why test3 is now, and this is test3. This is test3. So test3 is basically using the Fibo method that is inside this demo functions. Okay, that's why it is pointing to this now. Let's try and see if this works or not. Compile this, run this. Void main, and let's run. Now it is asking what? Okay, it is asking to enter the number, right? Let's enter probably 10. Let's see, 10 Fibonacci numbers, right? Okay, so let's see. 0 plus 1, oh sorry, 0 1, 0 plus 1 1, 1 plus 2 3, 3 plus 2 5, 5 plus 8 13, 13 plus 8 21, 20 plus 13 34, 34 plus 21 55. So it is working perfectly fine. It is working perfectly fine. Great stuff, great stuff. Okay, let's use some other method. So this is clear. We can use method inside another class within the current class. Current class is test3. We are using method that is existing in some other class. The method is in this, but I'm using the method inside this, so I can do that. Okay, can I use methods for multiple classes? Well, let's try that out. Why don't we? Let's see. Does this test have some other method? Okay, it has. Okay, let's try use this one. Mul. This is also a static method, right? Okay, let's try and use this. If I say enter number, enter number 1, I'll take two numbers. For division we need two numbers, right? So I'll take the first number x, int x is equals to sc dot next int. Okay, then again the user enters another number, enter number 2, and I take the number that this is going to be the y. Now I'll open test. Okay, let's use okay, let's use this one. Let's use multiply. Okay, so inside test3, what we'll do is that we'll say, okay, what was the class name? How do we call static functions from other classes? We use the class name. This is the class name. This is where multiply is there. Multiply method is there, and this is the class name where we are going to use the method. So we're going to say that I need to use the mul method that is inside test class, and I want to multiply x and y, and I want to store it. I want to store it. Maybe say n. I want to store it because it will anyway return integer. Let me check. Will it return integer? Yes, it returns an integer. Yes, it will return an integer. Did you see the pointer? Did you see the pointer? Exactly. What is it asking? Hey, what is it asking? Yeah, it is showing duplicate class test3. Why is it showing now? Why is it showing such things? Because within test class, if I open this, do you remember last time we created this test3 class within test class? Remember, we created multiple classes within the same test class, and one of the class was test3, if you remember properly. This is the reason this is getting conflicted. So just remove this. We don't need this anyway, right? So let's save this then. Let's save this and compile this. Yeah, okay. Now it is not showing any error. So test.multiply, we will multiply x and y. So this multiply method is within this test class, and I am using this method within this test3 class. Perfect. Now after this, what I'll do is that I'll check if that number, if n is a palindrome number, Armstrong number, or not. So how can I do it? I can say, okay, where was our palindrome number method contained? This one. This is where our what was there? Palindrome. This is the method that we need to use. Okay, how do I use it inside this test class? Very simple. What was the class where the is palindrome method is contained? This one. So simply write demo functions dot, and what was the method name? Is palindrome, and you simply send n like this. And of course you will be using ternary operator. If this is true, of course, then we would say palindrome, otherwise we would say not palindrome. and of course put everything inside system.out.println. System.out.println. Save this, compile this. Now look at this very carefully. Test 3 is using a method that is within this test class, and it is also using a method that is present within this class. So that is why functions are reusable. Are you getting my point now? You can have many functions written in some other classes, some other program, and you can again reuse it. You don't need to write the logic of the function again and again. You don't need to write the multiply function again. You don't need to write the is palindrome function again. That is the reusability part. That is something that reduces your effort while making software. This is why functions are reusable, and you can take the full advantage of it. That is exactly how, because you can have many projects, multiple projects, and you might have some functions, some methods that you have used in some other project, but now you need to use the same thing again. Will you write it? No, you reuse the same code from that existing project. That's how you do it. So in this case, test.mul refers to the multiply method that is contained within the test class. That is this one, correct? And when I say demo functions.isPalindrome, this refers to isPalindrome method that is existing within demo functions class. That is this one, this method. And we can use functions from multiple classes within a single class. And I save this, I compile this, and let's run this, and let's see if this works or not. Did you see what did you did? You combined things. So you first multiplied x and y, you kept it in this variable, then you use this variable inside another function that is coming from some another class. That is how you can combine the functionalities. You can what? You can combine functionalities. Okay, you can see you are using multiple methods from different classes, and you are using to your own need, right? So just compile this and let's run this. So it is asking for number one. I'd say by the way, yeah, number 1 is 4, number 2 is 6. Okay, so it is getting multiplied. So 6 4 is 24. 24 is not a palindrome number, right? Because 6 into 4 will give you 24 over here, and I'm sending 24 to palindrome number. 24 is not a palindrome number. What can I do? Is 13? Let me try. Let me think about it. Yeah. In fact, what I can do is this. Let's run this once more. Test 3. Run once again. Okay. I will enter 11. I will enter 11. Palindrome by 11 into 11 gives you 121. That is why it is a palindrome number. 11 into 11 is 121. 121 itself is the palindrome number. So that's how you can combine functionalities. Anyway, I won't extend this topic anyway. We are done with all these functions and everything. You know what? Basics of programming are completely done. You don't need to worry about the basics of programming anymore. We have covered loops, we have covered if-else, we have covered methods, we have covered variables, operators, how Java compiler and JVM works together, everything. We have done all of these things, and we have done a lot of exercises. Now, in the next video, I will start one of my most favorite topic, which is object-oriented programming, the core of Java, the heart of Java. Until then, have a good time. Bye-bye.